Hey everybody, thank you for clicking on this video. I appreciate your support. If you haven't already subscribed, please consider doing so. So for those that are new, what I do is I take electronic projects from old electronic magazines and I build them and then I bring them to life essentially. So if that interests you, or even if it doesn't interest you, try to hang in there a little bit. I'm not too technical. I just want to show you the process and the fun that I'm having. I'm here for the fun. That's what I am. If I educate a little bit, that's great, but I'm here for the fun. So what we got today is a level meter. So you know those bar graphs you see on stereos and such. So I'm going to build one of them. In fact, I'm going to build two for the left and right channel. And it comes from a project from Electronics International, or Electronics Today International. It's the December 1975 issue. That's an old one. We're talking, what, 44 years or something like that ago? And luckily, just luckily, I have all the parts for it. So what I'm showing you now is the I guess the authors or whoever built it or designed it, it's their version. So hopefully I can get something close to that. Okay, so right now we're looking at the schematic of the audio level meter. Now there's two of them, like I mentioned. And again, I'm not 100% sure how this works. I think I kind of got it before I experiment. But obviously the audio goes into the IC1/3. So IC1 are amplifiers, right? And the comparators are the ones connected to the LEDs on the right. So IC1 takes the input signal and amplifies it to a certain level. I think it's at 2.5 volts. I'm not too sure about that. And the IC11 at the very top left-hand corner, that's a peak detector. So for the positive end, and the one, the audio, well, the amplifier below it, that's the negative peak detector. And the bottom amplifier from the LM3900 IC14, that provides compensation for the 0.6 volt offset of the LM3900 inputs, the comparators. And of course we have a voltage divider in the middle, right? So that's how the different levels of the LEDs get triggered. And off to the right of that, there's two transistors, and that is for a constant current supply. So the magazine says 10 milliamps. That's the most that'll ever flow through this, which is fine. And I don't exactly know how the actual LEDs are triggered. I suspect it's on a specific voltage because of a voltage divider. But I don't know if I think it syncs down to IC1/4. But we'll have a good look at it when I get it built. And we'll put it under the scope and we'll understand that section a little bit more. And the very last image I'm showing you right now is the PC board. And that is cleaned up. So I copied it from the magazine. I put it into a photo editing program and cleaned it up, changed the contrast, and that's what we have. So that's it for the introduction. Next, I'm going to show you the parts and the PC board that I've already made. Okay, so there's the parts, and in the previous section of this video, I'd mentioned that the comparators were LM3900. That's not correct. I think I'm actually getting sick. I'm kind of losing my voice, and I've got a big headache. 339s. LM339 is the comparators. Anyway, I got the parts and the boards, IH2 right and left, and I've already drilled them. So I won't go through all the motions on that. I think you've already seen enough of that. So let me actually build the circuits and I'll bring you back in when it's... Okay, so good news and bad news. The good news is I've got both the boards populated, as you can see, and they work. The bad news is I've got a cold, and as you can tell, my voice is very scratchy. But I'm going to try to persevere and get through this video and then work on the next one. So let me just demonstrate what I've got going here. I've got one channel hooked up to my stereo, and I'll turn that on and turn the power supply on. And as you can see, the VU meter works. So actually there's two kind of configurations for this project. You can have a power meter or a VU meter. I decided to go with the power meter, and I pretty much have my stereo. Well, there's a table also in the project where, depending on the power output of your stereo, you have to change certain resistors. So I've got this one set pretty high. And in fact, I'm probably halfway on the stereo. And I think my Akai stereo puts out, I think 40 watts, 50 watts maybe. So, I'm in the 20 watt range. I should have looked at it. I should have looked up the specs before I started this little clip here, but needless to say, it works. And I'm just going to crank it up a little bit more. And you can see it's starting to flash, and then it'll turn completely off. So that's the section of the circuit that looks for peaks and then basically kind of shuts it down. So yeah, what else can be said? Oh, and another thing I noticed is this circuit looks very familiar to the LM3914. And sure enough, I pulled up the data sheet. In fact, I'll display that to you right now. It looks very similar to this circuit. And when I look at the dates, this project is from 1975, and the LM3914 was designed in 1980. So obviously they took this design and, made it a little bit better. But needless to say, this is probably the genesis of the LM3914. Anyway, so what I'm going to do now is I'm going to put these both these channels in a box, and I'll build a small power supply and then show you. So let me do that, and I'll bring it back in when I'm at that point. Okay, so good news. The project is done. I've got it in the box, as you can see. The bad news is I'm still sick. But it could be worse. I could have the flu, but I don't. It's just some sort of a cold or something like that. Anyway, I built the power supply on a terminal tie strip. And you can kind of see the regulator, or not the regulator, the bridge rectifier, capacitor, and then there's the 12 volt reg. Well, the small mylar capacitor at the end of it. So that gives me 12 volts, which is just perfect for this power meter. I also found a small little transformer. I think I got that from an old small-ish ghetto blaster. Great source for little transformers. And of course, we got the AC coming in and going through a fuse to this power switch, and of course completing the circuit to the transformer. And there's my two inputs for the audio. And yeah, I guess that pretty much does it. I mean, let me put the cover on, and then I'll demonstrate it for you. Okay, so right now I've got the stereo power meter connected to my actual stereo, my Akai stereo. So I've got it on FM right now, and you can actually see the left and right channels. And what I'll do is I'll turn the balance to the left, and I'll turn the balance to the right. And that's the center. And then I'll just go through the band, and you can kind of see some dead spots. There's a dead spot there. Anyway, you can clearly see that it's working. I'll turn up the volume a little bit on one of these stations here, if I can get one. There's one there. So I'll turn up the volume on that. And again, I'm at like 3/4. So that's a lot of my stereo. So I'm definitely overdriving it. In any event, so that is my stereo power meter from December 1975. It's such a long time ago. It comes from Electronics Today International. So I hope you enjoyed that. Sorry about my sickness and my sore throat and all the rest of it, but I will get better, and I will bring you another project. So if you haven't already checked out some of my other videos, please check them out and give them a go. I am working on another project. In fact, I've got a couple of projects on the go. So hopefully I'll have another one out next week sometime. And I hope you enjoyed this one. Bye for now.